Hello, everyone. Welcome to the second coding workshop of the Rust on Linera Spring 2024 Hackathon. We're excited that you guys can all be here. Today, I'm here with Christos, who's the software engineer of Linera. We're going to play a recorded video for the coding portion, but then we will also be here live to answer any questions afterwards, should you guys have any. Yeah, that we'll have another coding workshop on the same day next week. And if you guys have any other questions, make sure to just email jesse.paracelli@linera.io if you have any hackathon specific questions. Yeah, I'll pass the mic over to Christos to just kind of introduce what we're about to watch.
Yeah, hey everyone. Nothing much to add. I think you did a good job introducing it. This is the second workshop, building up from the first. We're going to be doing some integration testing and adding instantiation arguments to our program to make it a little bit more flexible and generic for people to use. Yeah, so Jesse, let's get started.
Great.
Hello and welcome everyone to the second workshop of the Linera Spring Hackathon. My name is Christos. I'm a software engineer at Linera. And today we're going to be building on the work we did in the first hackathon, the first workshop, by adding two things to our application. The first thing we're going to do is we're going to add some instantiation arguments so that the user can specify the amount of tokens that the application starts off with. And the second is we're going to be adding some tests to test that our application is behaving as we expect it to behave. So let's start with the instantiation arguments. Let's go over to contract.rs and we'll work with the instantiate method. So as you can see on line 40, we're hard coding the amount, 1,000,000 tokens. But let's change things a little bit so that the user can select how many tokens they start with. So to do that, I'm just going to delete line 40. And I'm going to go to the associated type of the contract instantiation argument, and I'm going to change that to amount. Again, if you recall, amount is just a wrapper around an 128 bits unsigned integer. And what we're going to do here is we're going to also change the name of the argument to the instantiate function to amount as well, instead of, what was it before? Argument. Yeah. Perfect, so it's kind of that simple. Let's quickly compile our application, check that everything works. Okay, so we're no longer using standard string from string, since there's no longer explicit parsing here. So we're just going to remove that. The parsing is done elsewhere in the stack. We'll go check again. Okay, cool. So let's deploy the application with an arbitrary amount of tokens that we're going to specify right now. To do that, we're going to use the publish and create command again. So Linera project publish and create. Excuse me. And we'll use the help to figure out which argument, which options we want to choose. So there's a few we can choose. We can specify our JSON arguments from a path pointing to a file with JSON, or we can specify them in line with --JSON argument. And that's what we're going to do, I think. So we're just going to do --JSON argument. And we're going to specify this as a string because, again, as I said, amounts are 128-bit and JSON number types only go up to 64-bit. Well, yeah, I think both integer and floating point go up to 64-bit. So we're just going to specify 100 tokens here, and we're going to put it in escaped quotes as well. And we're just going to publish that real quick. It's going to compile, publish the bytecode initially, and then once the bytecode is published, instantiate the application using that bytecode. Okay, perfect. So let's head over to Linera service real quick, as we did last time. Okay, so let's list the chains. No, my bad. Actually, we need the chain ID here first. So let me just get that real quick. Linera wallet show. Get the chain ID 108. Restart the service. And then here we're going to list all the applications corresponding to that chain. And we're just going to list the links. That's the link for our application, which opens up the GraphQL ID for that app. And now what we're going to do is we are going to, like last time, we're going to list the counts, and we're going to get all the keys. There should only be one key, which is the owner that published the application. So FFBD, and then we're going to get the entry for that key. And we should hopefully see an amount of 100 here. And indeed we do. So yeah, we deployed a new application and we explicitly specified the instantiation argument as 100, and that's the instantiation argument done. Okay, so now that we've specified the instantiation argument, what we want to do next is we want to write some tests for applications so that we know that it works correctly. And in order to do that, what we're going to do is we are going to create, well, actually, first of all, we want to add some more dev dependencies to our cargo toml. The reason for this is to run integration tests. What you do is you start something like a mock validator, which works on asynchronous code. So we need to add things like dependencies on the Linera service and also Tokyo. So let's do that real quick. First, we're going to add a dependency on the Linera service, and we're going to be explicit about the version 0.11.3, and we're going to add the test feature. So features test. Okay. And next, we're going to specify our dependency to Tokyo. Oops. Tokyo. The version is 1.25.0, and the features that we're going to be using are the macros feature and the multi-threaded runtime. So RT multi-thread. Okay, let's just cargo format real quick. Cargo format, just to make sure everything is nice. One more thing we need to do is to our Linera SDK dev dependency, we want to add the WASMer feature here, which is the WASM VM we're going to be using to actually run, to actually test our application. Okay, cool. So let's just check that everything compiles again. Nothing should have really changed. Perfect. So to add integration tests to your application, you can add a directory called tests. So make dir tests, and then we'll cd into tests, and we'll touch. You can name this file whatever you want, but I'm going to name it crosschain.rs because we're going to test cross-chain functionality in our integration tests. Okay, I'm just going to open cross-chain here real quick. Perfect. Now at the very top, what we want to add is the fact that we don't want this to run on WASM 32. This is important. And we're just going to create a code block which is going to be annotated with Tokyo test, indicating that this is going to be tested using the Tokyo runtime, and therefore we can have asynchronous functions. And we're going to name our first asynchronous function test cross-chain transfer. Okay. So what we want to do here basically is we want to test that we're going to send money from one account to another account on a different chain, and we're going to just assert that the money got there correctly. So our initial amount is going to be an amount, that's not the right amount, I don't think. We want the Linera SDK base amount. Base amount is going to be 1 million. $128, and the amount we're going to transfer is 50,000. Okay, now what we want to do is we want to start a validator, which is going to be using the current bytecode of the project we're in. So let validator, and then the bytecode ID here. This function is going to return a tuple. Test validator with current bytecode dot, oh wait. Okay, and if we go to this method here, we can see that this creates a test validator with a single chain with a bytecode of the crate calling this method to publish it. So it does a little bit of the heavy lifting for you. You don't need to explicitly publish the bytecode. This method's gonna just help out with that. And the sender chain that we're gonna be sending funds from we're just going to get that from the test validator. So new chain dot await. And the sender account is going to be the public key of the sender chain. So it's the chain itself that's sending the funds. Public, whoops, key. Okay, perfect. And we need to import owner from Linera SDK base. And then we can just panic here and run a cargo check. Perhaps all targets. Because the Rust toolchain we have here specifies the WASM32 unknown target. So this is going to compile this as well. Cannot infer ABI. Okay, that's fine. We're going to infer the ABI implicitly a little bit further on, so let's just keep on going. So let's actually create the application. And this is where we're going to be implicitly specifying the ABI that we're going to be using. So to deploy the application, we're going to be using the sender chain, and we're going to be creating the application. And this is where this function is generic over an application ABI. And in this case, we're going to be using the application ABI from myfungible. And then it's generic over two more types, which we're just going to leave as underscores here because they can be inferred implicitly. So it's the ABI, the parameters, and the instantiation arguments. But these two, I think, will be implicitly determined. So yeah, to create the application, what we need to do is specify the bytecode ID, the parameters, the instantiation argument, which is our initial amount, and the required application IDs, which we're not going to be using. This is if your application depends on any other applications, which ours doesn't really. So let's specify the bytecode ID here. We have no parameters, so that's empty. Our instantiation argument, which we defined earlier, is the initial amount, and this is going to be an empty vector. And finally, we're going to await this because this is an asynchronous function. So if we panic again, and now we cargo check, we compile. I mean, there's some warnings because we have some unused variables, but it compiles because the generic types here are implicitly inferred from our application API here. Perfect. Let's move on. We have our sender chain. We want our receiver chain set up as well. So we're going to set up a receiver chain. And we're just going to do the same thing we did earlier, validator.newChain, and a receiver account, which we can make the, which can just be the public key of the new chain, receiver chain.public key. Okay, perfect. So now what we're going to do is we're going to add a new block explicitly to the sender chain, which is going to contain the operation to transfer funds to the receiver chain. So there's a convenient add block method on the chain here, which takes a mutable reference to a block, oops, and a function. So block with operation, and the operation takes two arguments. The first is the application ID, which is generic over the ABI, which I think here is defined implicitly, and an operation, which implements 2 BCS bytes, which our operation does anyway. So our transfer operation implements 2 BCS bytes already. So we're just gonna add our application ID here and operation transfer. And if you recall from last time, operation transfer has 3 fields. So the owner, which is the sender account, the amount that we're going to be transferring, which we've already defined up here, the transfer amount, and finally the target account, which is an account where there's two variables, chain ID, receiver chain.id, and the owner that we're sending it to, the account owner, which is the receiver account on line 21. Perfect. And this is asynchronous, so we're also going to await it. Let's just format this real quick to make sure everything is nice and lined up. And something is not happy here. I think it's just if we need a semicolon here. Perfect. Okay, so the first thing we're going to do is we're going to make sure that the balance on the sending chain has decreased by the transfer amount. Then we're going to receive the messages on the receiver chain, which we need to do explicitly, and then we're going to make sure that the receiver account has the transfer amount. So we're going to do assert equals query account, which is a method that we have not defined yet. We will in a bit. So query application ID. It's going to take 3 arguments: the application, the sender chain, and the sender account. And it's going to give us back a balance, which is going to be equal to an optional. So in this case, we have initial amount dot minus the transfer amount. Okay, and that should be good. We'll get on to receiving messages on the receiver chain later, but for now we'll create the query account function. And as we said, yeah, this takes an application ID generic over an ABI. So this is fungible. This is application ABI here. It takes an active chain, a reference to an active chain, and an owner. This is all correct. Let's just name them a little bit better. My ID didn't do a great job. So application ID. Oops, my bad. Like this. Then chain, and then the account owner. Okay, cool. So what we're going to do is we're going to query using GraphQL actually. So we're going to be writing some GraphQL inline here as a literal string. So format query counts. This is the same thing as we did in the service earlier. So entry key is here. And this is the value we want to return. And then we want the account to value. So there should be a method which converts it to a GraphQL input type, and there is. Perfect. Now the response is just going to be returned by the chain. So chain.graphql query. Again, there's this convenience method where you can perform arbitrary GraphQL queries against these chains. All we need to specify is the application ID, which we have already, and the query itself. Perfect. And this is asynchronous, so we'll await it. And finally, the balance is going to be given by the response, and there is this pointer method here. And what pointer does is it allows you to look up a value in a JSON response by a pointer, so that we don't have to kind of manually traverse the entire JSON tree, but instead we can do counts entry and value. This is optional because it may not exist. Whoops, that's not meant to be a dot. And we know it's a string, so we are going to do as here, again, returning an optional if it's not indeed a string, but this is fine. And then finally, we're going to return an amount. So sum balance, parse the balance, and unwrap if we can't parse it for some reason. Actually, no, let's be a bit more descriptive here and add an expect count balance cannot be parsed number. Perfect. Something's missing here, and I think that's the actual return type of the function. I forgot that, which is option of type mount. Cool. Let's cargo check, make sure everything compiles. Looks like it does. And now to test that this works, we're going to do Linera project. We're going to use the test subcommand. So Linera project test is going to compile everything, and it's going to run the integration test. They're going to take a little bit longer because we need to start the validators and the asynchronous runtimes and all that stuff, but hopefully our test should go green. Perfect. The test passed successfully. So next, excuse me, we want to handle the received messages on the receiver chain so that the account balance for that application updates. So we're just going to do receiver chain, excuse me, dot handle received messages. And again, this is asynchronous, so we'll await it. I think, okay, it's not complaining anymore. Cool. And now we should be able to just assert that if we query the application ID on the receiver chain for the receiver account, we should just get the transfer amount, right? Because that account had 0 to begin with. So let's just run that again quickly. Yeah, looks like everything passed. Okay, perfect. So, yeah, I mean, in the beginning, we added instantiation arguments to enable users to customize the initial amount of tokens that the application starts off with. And then we tested that all the functionality we've written up to this point actually works by adding these integration tests. In the next workshop, we're going to be adding some more tests, some logging, and more fun stuff. So yeah, feel free to join in for the next one.
Okay, perfect. Thank you, Christos, for that overview. Um, we're gonna we can ask questions now. If there's any questions, we'll give about 2 minutes, 1 minute in the chat right now to just see if there's any questions. If not, you guys are welcome to just reach out to us on Discord. And you can ask any technical questions in either the Hackathon channel or in the dev channel. We'll give it about 30 seconds. There's also a new example application that was released the other day called Hex. So if you guys are working on a gaming track, you'll be able to use this example application as something to hopefully help with your project that you're working on. Okay. No questions. We will do this again next week. And we're looking forward to seeing all of you guys there. I'll see you guys later. Thank you, Christos.
But guys,